Hello everyone, welcome. I'm Rama Balapudi, OPM for AlloyDB, and today I'm excited to showcase the new fully managed remote MCP server for AlloyDB. Joining me is Paul Ramsey, Product Manager for AlloyDB AI. In this session, you will discover how to enable the AlloyDB remote MCP server and securely connect it to an agentic application with no cumbersome infrastructure to provision or manage. The reliability of agentic outcomes is based entirely on the data and quality of the context the agent can access. The Model Context Protocol, MCP, addresses this problem by establishing a single protocol that connects AI agents directly with your source of truth, replacing fragmented integrations. Today, we are bringing that power to AlloyDB. Let's see it in action. I'll hand it over to Paul, who will walk us through a short demo.
Thanks, Rama. Let's see how easy it is to get started with the new remote MCP server for AlloyDB. We'll look at this through the lens of a fictional supply chain company called Symbol Logistics, where I'll play the role of a fleet manager using an AI agent built on the Google Agent Development Kit. So let's say I want to review the performance of my delivery drivers based on recent customer ratings and reviews. So I'll ask my agent, show me the latest reviews for my drivers. The agent thinks for a moment, but then it provides a pretty disappointing response. It turns out it doesn't have access to that data. Of course, models are only as useful as the context they can access, and that's where the AlloyDB remote MCP server comes in. It eliminates the need for complex, unmanaged infrastructure by providing a secure, HTTP based interface to access the real time operational data that I need to run my business. And I can set this up in just a few simple steps. First, I'll go to the built-in Cloud Shell editor, where I'll enable the data API on my AlloyDB instance, which I can do with a quick curl command. Next, I'll add a few lines of code to my ADK agent to set up the AlloyDB remote MCP server. I'll do that by adding the tool to my configuration and defining the connection details. Thanks to our native integration with Google Cloud IAM, I can use a standard OAuth token for fine-grained access control. And because the MCP server is fully managed, there's no need to handle database connection pools or infrastructure. Finally, I've specified the database details in the prompt, so the tool knows exactly which AlloyDB instance to access. With the API enabled and the MCP server configured, my agent now has direct access to my source of truth. So now when I ask my agent for driver performance, the agent delivers. You'll notice as the agent runs that it makes several function calls to our AlloyDB remote MCP server. The agent runs introspection queries to learn what data is available to answer my question. The agent will then remember this context during the session, making subsequent questions about the same tables even faster. And here are my results. It looks like we have some mixed reviews, with some drivers receiving accolades and others maybe in need of coaching. Notice as I tab through the queries, the agent started by looking for which tables were available, then for which columns, and finally it was able to write a query that joins multiple tables to answer my question. Now let's get a list of my top drivers so that I can give them a performance-based award to thank them for their hard work. So I'll say, who are my top 5 rated drivers? This time, the agent will remember the available tables, and it can immediately run the relevant query. But it looks like we have a tie for first place. So how do I decide who's actually number 1? I can actually use AlloyDB's AI functions to break the tie by evaluating the subjective quality of customer feedback. So I'll say, who are my top 5 drivers, and use the AI.rank function on customer reviews to break any ties. AlloyDB AI provides multiple functions that allow you to use natural language and SQL queries to express filtering conditions, analyze sentiment, generate content, run forecasts, and more. The power of AI models brings reasoning and real world knowledge to SQL queries, unlocking deep semantic insights from your enterprise data. You can generate vector embeddings, perform similarity searches, and even invoke AI models within a single query. Or, in this case, you can rank by subjective criteria. And here are my results. It turns out that Joshua Torres has the best subjective reviews from customers. If we look at the query, we can see that the agent retrieved driver reviews. Then it used the AI.rank function with the semantic ranker 512 model to fine tune the results. But what if a user asks for data they shouldn't have access to? For example, this database contains social security numbers of all of my drivers, but that's clearly not data that's necessary for me to do my job. If I ask the agent to show me social security numbers for all of my drivers, what happens? Well, in addition to fine grained access control in the database, we also provide an extra layer of security for our remote MCP servers with a deep integration with Model Armor. It enforces a governance floor, automatically redacting PII or blocking malicious content before it ever hits the agent. This isn't just about queries either. Whether it's managing backups, instance updates, or security provisioning, the AlloyDB remote MCP server handles it all through a simple natural language interface. Back to you, Rama.
Setting up MCP for AlloyDB is remarkably straightforward, as you have just seen. This integration allows you to develop agents that have direct access to your data rather than operating in isolation. On behalf of Paul and myself, thank you once again for joining us today.